Good morning, my YouTube viewers. It's Crystal here, and I'm here this morning because I wanted to give you another code review. What I wanted to do is I wanted to show you how to use R datasets and practice your data science projects with R datasets. And so basically, I found a repository that contains R datasets, and I'm using them. And it's going to be a really interesting code review, so we'll go ahead and commence with it. So the first thing that you do is we've got this GitHub repository in our datasets here, which I think I've got right here. Yeah, and then you can go into it and you can pick out the data sets you want. But what I will say is some of the data sets didn't work, but it's a good GitHub repository to look at. And so the next thing, after we've picked out the data set that we want to use in the GitHub repository, what we want to do is we want to create a program. And I've created this program called R Datasets statsmodels v sklearn affairs.ipynb. And the thing is it just started out as R datasets, but as I got into practicing on the dataset, I realized there were problems with stats models, so I had to go in and use sklearn to compare it. So now we've got stats models, which is what I originally wanted to use, and then we had to put sklearn in there as a comparison. So you'll find out we're going to compare stats models to sklearn, and you'll be able to decide for yourself which logistic regression tool you want to use. Do you want to use stats models or do you want to use sklearn? And so as we go through the code review, you'll find that out. So the first thing that we do after we created our library and picked our data set is we want to import our libraries. Sorry, after we picked our data set and created our program, we want to import our libraries. So we're going to import pandas as PD. Pandas is a data processing library that enables us to create data frames and maintain them. We're going to import NumPy as NP. NumPy carries out numerical calculations. It creates NumPy arrays, and it will also do linear algebra for you. We're going to import math. And math has some more complex mathematical operations in type Python. Math is an inbuilt library in Python. We're going to import statsmodels.api as SM. Statsmodels was what I originally wanted to use, but as you'll find out as we get into the program, you'll find out why I had to go in and use sklearn. We're going to import matplotlib.pyplot as PLT, and that's a graphics library. Enables us to plot the data points onto a graph and make our program visual, because it's always good to visualize the data, because when you visualize the data, you have more understanding of the data. And then we're going to import Seaborn as SMS. And what that's going to do is it's a higher level graphics program written on the back of Matplotlib. It enables you to do more complex graphics. So we're going to do that. So then we're going to load our data set. So I've already showed you the website that we got the data set from. And I don't know, it's this guy. He did this guy that did the data set, he just got a hold of all of the data sets and put them onto a GitHub repository. And one thing that I found out whenever I was looking for the data sets, there's not a lot of documentation on it, and because there's not a lot of documentation on it, you have to go through and look for the documentation, because the stats model website is not very good on providing documentation, providing practice code, and the our website is not very good at providing documentation either. So as a result of that, I had to go through and look on the internet, and I usually have to end up looking at YouTube videos to find the information that I need, because it's not on a website. So that's why I'm showing this to you, and obviously I got this information from a YouTube video because it's not on a website. I mean, both R and statsmodels are not very good with their documentation. They're not very good giving practice code, so you just have to kind of wing it. So we're going to use an affairs data set because it was just the very first one on the list, and I thought, okay, well, I'll try this. So data equals sm.datasets.get _ R dataset. And then affairs is like the little keyword that the dataset is, and then AER is the little group that it's in. So I'll show that to you here. I'm not going to move away from where I am because I'm going to be doing another data set too, but I'm going to be using spam email data. So spam 7 is the name of the data set, and DAAG is the group that it belongs to. So what I found out when I was looking for data sets is that for some reason a lot of them didn't work. Don't ask me why. So I hope the spam one works because I want to use that next, and I'll make a code review on that next. But here we're using the affairs. So we print the data dot, and it tells you the rating. And the rating is a multi-classification, and so rather than, it's not binary, it has five ratings. 1 is very unhappy, 2 is somewhat unhappy, 3 is average, 4 is happier than average, and 5 is very happy. And so that's your target value, or your label as your rating. And then it gives you some more information that I really personally didn't read a lot of, because I just wanted the data set. But if you want to read it, you can. And then so in order to show the data on the screen, you have to go data.data, and then so that will show the data on the screen. And then here's another area that there's not any documentation on this. I just guessed. If I didn't guess, then, and it didn't work, then I probably wouldn't be using this website with this data set, but I just guessed. And I said data equals data.data, and by some miracle it actually happened to work, because as I said, there's not a lot of documentation on how to use these R data sets in Python, and there's not documentation on how to use the statsmodels data sets in Python. And so really, in order for me to get it to work, it's just trial and error, because there's nothing written down. The only way you're going to know is if someone puts it in a YouTube video and you watch the YouTube video. So you've got a column called affairs that tells you how many affairs the person has had. You have their gender, you have their age, you have their years marriage, you have your children, you have their religiousness, their education, their occupation, and their rating. And so the education, you can pretty much guess that. If they've got 12 years of education, it means that they went to high school, and anything above 12 years is going to college and university. And so I just pretty much guessed that. But occupation, they don't give you information on the occupation, so we don't know what their occupation is. But anyway, So now we're going to analyze the data. So we do a data.info. So you've got 2 object columns, and the rest of them are numeric. They're either floats or integers. Now what we're going to do is we're going to check for unique values. So I did a for loop to check for unique values. For call if data unique values equals data call unique, print column name call, print unique values, and so for every column, now you know what the unique values are, and so you can determine what you want to do, how you want to process this data after you know what all the unique values were. So I think that's neat. So you have 2 object columns. The one object column is gender, it's either male or female, and the next object column is children, it's either no or yes. So now what we're going to do is we're going to encode the categorical values, and we're going to do that by replacing the objects with numbers. So in the gender column, a male is going to be 1 and a female is going to be 2. I didn't put any one of those as 0 because I just felt that it had like negative connotations if you gave one 0. So I gave the male 1 and the female 2. And on the children, the no is a 0 and a yes is 1, so that's sort of like a binary logic. And then so we check our data frame, and you can see that the genders are either a 1 or a 2, and the children is either 0 or 1. So we're going to check for missing values. We don't have any missing values, so we don't have anything to impute. And now what we're going to do is we're going to actually analyze the data set. So we're going to check the rating using sklearn, sns.dispplot, data.rating, and so you can see that this is the rating of the marriage. I mean, most people were happy in the marriage, and then it went down to not so happy and all the way down. But it's really interesting to know that most people were happy in their marriage. And now what we're going to do is we're going to check out some box plots, and the box plots will give you a good rating as well. So this right here tells you the number of affairs a person has had and the happiness they are experiencing in their marriage. So if they had 0 affairs, they were the happiest with the exception of a few outliers. But it's like the more affairs that they've had, the less happy they are in their marriage. So you can see the person that's had 12 affairs, they're going to be less happy than the people who've had 0 affairs. So that's interesting. Now we're going to do another box plot with gender and the rating, and you can see that the genders were pretty much equidistant. But one thing that we can do here is we can come over here and we can go sns dot ISLOT. So we'll just run that. So the male is 1 and the female is 2, but we're just running that just to see how many males and females you had. So you had slightly more females in the data collection process than you had males. Okay. And then it comes here with the age, and it says that generally the younger a person was, the happier they were going to be in their marriage. And so like the person that was 57, they were going to be the least happy in their marriage. So that was interesting. And the next one, we've got the years married. And basically, the longer that a person was married, with the least happy they were going to be in their marriage, because the person was married at 7 years. So you can see that there's a 7-year itch, and then the person that was married 15 years. And so, with the exception of the person that was married for 10 years, you can say that the longer a person's been married, the likelihood of happiness going down is going to increase, except for the person that was married in 0.75 years, their happiness wasn't very good either. Now we're going to check the children rating. So the people that didn't have children were going to be more happy in their marriage than the people that did have children. So children decrease happiness in a marriage. But what we'll do is we'll just see how many children we've got in there. We're going to use Seaborn. Let's see what happens. So more people had children than didn't have children, and the people that had children were less happy in their marriage than the people who didn't have children, except for a few outliers. And then what we're going to do is we're going to check the religiousness. And so the people who were least religious were happier in their marriage, except for a few outliers, than the people who had more religiousness. Now we're going to check education. And this is another thing that's interesting. People who were more highly educated were more happy in their marriage than the people who were less highly educated. So you can see the people who only had 9 years of education, they were less happy in their marriage than the people who had 20 years of education. So that's very interesting, you know. I know me personally, I can just tell you a little bit of my background. I don't have a PhD, but I have a master's degree. So I have the equivalent of I have the equivalent of 18 years of education. And me personally, I didn't get a PhD because, well, I can't afford to get a PhD now. Now it's a bit useless for me to get a PhD because of my financial situation. And because of my financial situation, I can't do a PhD. But I always thought, whenever I got an education, I always thought, oh, well, I'm going to get this education and I'm going to get a nice job and make a lot of money. And, well, it didn't work out that way, which is why I'm creating content now, because I didn't get a nice job and make a lot of money. Well, I did have a nice job and made a lot of money, but that's for another video. That's not for this video. But, and I always thought, well, I'm just getting an education so I can make money. And then I would be in relationships. And so the people who I were in the relationship with, they thought that they were just going to live off me. And I didn't think that. I thought, well, when I get this job and make a lot of money, I'm not going to hang around. So that's really interesting to say that people who are more highly educated are happier in their marriage, because I didn't really feel that way at all. So I guess maybe I'm one of these little outliers here. But I don't have 20 years of education. I have, I guess, 18 years of education, because I have a master's degree, because 4-year college and 2-year master's degree. So that's 6 plus 12 is 18. So I never quite made it to the PhD. So I don't have my 20 years education. So that's just so you'll know a little bit about me in this code review. And I was just telling you a little bit of my personal experience when it talks about happiness in a marriage. or in a relationship in my case. So now we look at another box plot. We look at occupation, and they didn't give me any information on the occupation, so I can't really comment on that except to say that people in occupation number 7 seem to be less happy than the other occupations. So after we've analyzed the data, we're going to do a heat map, and so we're going to do a heat map of the correlation. So the people where it's dark, it's going to be a lower correlation, and where it's light, it's going to be a higher correlation. So we don't have a whole lot of columns here. I think we've only got like 9 columns, I think. Let me see what it says. Yep, we've got 9 columns. So that's not an incredible amount of columns. But what you can do is you can insert some code here. And what this code will do is it will drop any columns that have a high correlation. So fortunately, it didn't drop the rating, because if it had dropped the rating, I'd have to go through and do some changes. But none of the columns were dropped. But anyway, just to try to keep the number of columns to a minimum, to try to keep the noise and the redundancy to a minimum, you insert that code to remove columns with a high correlation, but none of the columns had a high correlation, so none of them were deleted or removed. And so now what we do is we define our X and our Y variables. Y is data rating, and then we're going to drop the rating from the data set, and X is the data after we've dropped the rating from the data set. So you can see that the X data set, there's no longer a rating there because that's been dropped. So now what we're going to do is we're going to normalize the data. So I'm going to come over here, because whenever I was going through the model, I was trying to do whatever I could think to do to get the model to work. And so generally in logistic regression, they say that you don't have to normalize it. But what you do is you check it being normalized, and then you check it not being normalized. So because I couldn't really get the accuracy at a high level, I tried to remove the normalization. So that's what you do. You check with normalization and then not normalization, and then you pick the highest one. But we're going to stick with normalization. And what normalization does is it takes the data and it converts all of the cell values to a value between 0 and 1, because the model is able to make predictions better if the data is normalized. So that's why you check it with normalized data, and then you check it without normalized data, and then you pick the method that's going to be best. And now what we're going to do is we're going to split the data for training and testing. So train size equals int ln x times 0.9. So your training data is going to be 90% and your testing data is going to be 10%. X train equals x, the beginning to the train size. Y train equals y, the beginning to the train size. X val equals x, a train size to the end. Y val equals y, train size to the end. And then we check our shapes of x train, y train, x val, y val, just to make sure it's okay. So we've done that. So now the data is completely pre-processed, and it's split into training and validating data sets. So we're going to look at stats models, because that's what I'm working on at the moment, is stats models. So we're going to import stats models.discrete model as sm. So model equals sm.MNLogit. Y train, X train, fit method equals BFGS, max ITER equals 1000, and then summary equals model.summary, summary. And so now what you do is you get it prints you out a summary of what's going on with this. So it said it went through 240 iterations. And then it gives you lots of other information that if you are a statistician, you're going to know all this information. But I'm not a statistician yet. So I can tell you that this is your coefficient, this is your standard deviation error, this is your z value, this is your p greater than z value, and this is 25% and 0.025% and 0.975%, and that's something to do like with the Gaussian distribution. So those are like the tails of your data, and it's something to do with like the bell-shaped distribution. And if you are a statistician, then you're going to know all this information and you're going to be able to find it useful. But because I'm not yet a statistician, I can't really give you a lot of information on it except for to tell you what it is. Okay, and then what we're going to do is params equals model.params. So, and then we're going to print the params. I'm not sure exactly what params is, but that's just another thing that you want to look at when you're doing your predictions. One thing to note about the param is it gives you a table with 4 columns in it. And so what we'll do is I'm going to do a blog post on this, and whenever I do the blog post on this, I'll talk about what params are. I'll look it up and put it in my blog post, because that's what I do. Is after I do a code review, I go through and do the blog post. And so it's always really good for me to do the code review, because when I'm doing the code review, I can find out things. I can think, oh, well, I should have done this or I should have done that. And then so I'll do all the things that I should have done or correct any errors. And then I'll do a blog post. And so it should be error-free by the time I get around to doing the blog post. So ypred equals model.predict xval. And what is interesting in this prediction is it gives you a table with 5 columns of data. So I'm not sure exactly why it gives you 5 columns of data, but that's what it does. And then so ypred equals np.asArray, ypred argmax1. And then what you do is when you do that, it will give you the highest probability of the data. And the thing that I found a little bit exasperating was in this array of data, which is 61 values, there's not 1 5 in there. And so since there's not 1 5 in there, it's going to be a little bit difficult for the rating to work. But it's got a 0 in here. And if we go back and look at our unique values, we're just going to go back and look at our unique values. There's not even any 0 there, so that's a problem. That is a big problem, because it even gave you a 0 as an answer when there's not a 0 there. So, I mean, what we could do is we could say y and equals y. I'm just trying this out because you can see I had a really low accuracy, though there's not going to be much that's going to, you know, hopefully that will improve it, because it had a 0 in there, and so it shouldn't have a 0. So we've got a 5 in there, so the ones that have a 0, and that actually improved our accuracy. Our accuracy is really poor, so that's something to look at. So we kind of like had to artificially manipulate the data, because the logistic regression isn't even working. It was giving you a value of between 0 and 4, but what you wanted was a value between 1 and 5. So we did I was actually able to use this logic to get some ones in there, but I don't know if it's necessarily a good logic, but it's something I did because, and that was why I spent so much time last night trying to figure out what the problem was, because the model just wasn't working, you know. So what are we going to do? So yeah, we've improved our score by getting rid of the zeros, by saying y pred equals y plus 1. So now you have value between 1 and 5 instead of a value between 0 and 4. And that actually increased our accuracy from 0.14 to a 0.34. So it's still really low, but it's a little bit higher. And then so here we're going to compare the actual values against the predicted values. And so that wasn't very good. And so since it wasn't very good, I thought, well, let me check sklearn. Let's check sklearn and see what happens. Well, when you use sklearn, so let's look over here where it says sklearn here. It says multi-class. It's going to be multinomial. Let's make multi-class multinomial and see what happens. And just make sure I got the multi-class correct. Yeah. So let's try it again and see if we can improve our accuracy if we make our multi-class multinomial. Because it is a multinomial target. Nope. Didn't improve it. Or if it did improve it, not very much. And so we predict on it. Y pred equals model predict x val, model score x val, y val. So we had a 31% accuracy. So that's not very good, but hey ho. And then here's our y pred. So here you don't have any ones in there. So you've got 2s, 5s, 4s, and 1, 3. So, but you don't have any ones. So that sort of like messes up your reading. So there's not any ones in there. So again, we've not got any ones. So you could say this just to try to get some ones. I'm not sure exactly what to do. We'll just leave it. I was going to try to do some mathematics manipulations, but that's still not solving the problem because we've not got any. We've got 2s, 5s, 4s, and a few 3s, but I don't see any 1s. See, let's try this. No, that didn't work. Let's see what's going on. Let's see what happens. It says it has no attribute unique, which is a bit strange. It should have an attribute unique. Try that. There we go. Let's see what we got here. So it's showing you there that there's not any unique values of 1. So again, that's not working very well either. So this is not a very good data set to practice on. So, I mean, I already knew that, but I thought, well, I'll just check. So it's got a higher accuracy, a higher level accuracy than the stats models, but it's still not good. And then so what we do after that, we use the data frame and we compare our actual values against the predicted values. And so that's it, really. That concludes this code review. I've done a few little things that I could do to try to improve my score. And you can see for yourself what it's like. And we're just running it one more time. And that's it. That concludes this code review. So I hope you got something out of it. So one thing that you learned in this code review was you learned how to call up a data set from R to use it. And then another thing that you learned was that stats models documentation isn't very good and that R's documentation isn't very good. And that's probably why so many people use sklearn, because the stats models MNLogit didn't perform as well as sklearn's LogisticRegression. And since it didn't perform as well, I guess that's why people prefer to use sklearn. But I'm going to do another video and try to find something that's binary and see how stats models performs with just a binary target. So I'm going to go ahead and close this code review because I've been speaking for a long time, and I tried to show you as much stuff as I possibly could show you. And I'm going to thank you so much for watching my video. And if you like my video, please like, subscribe, and share. And thank you so much for subscribing to my channel and supporting me. And I will make more videos for you in the future. So thank you again and have a nice day.